Hello everyone again. Okay, so this is the last lecture for SHP, lecture 18, and the last one on statistics. Okay, so this is about your standard normal distribution curve. Okay, so this curve is symmetrical on both left and the right side of the mean. Okay, so let's go straight to it. Okay, so we will take a look at some of the distribution curve, normal distribution curve properties, and then your favorite Z value again. So if you have been paying attention in the last lecture, you would roughly know how to use the Z table. Okay, so it's similar, it's the same thing. Okay, except a different application. Right? Okay, so we will see the curves, then we see again the Z table one more time. So this is a distribution curve. This normal distribution curve is a descriptive model. Okay, it's for quantitative. That means you can calculate. All right, so it has infinite range. It can goes on and on. And this is, of course, a distribution that's normally seen. That's why it's called a normal distribution curve. The mean, mode, and median are found at the center of the curve. Okay, so when you draw a normal distribution curve, the mean will always be in the center. Okay, it must be continuous, of course, no gaps in between, evenly distributed about the mean. That's what I'm saying just now. Okay, from the left and right. So that's why they are symmetrical. And the total area under the curve is 100% or 1. Okay, usually we use percent. Okay, 100%. There's only one mode in this normal distribution curve. Okay, so it will look something like curve A. So this is the normal distribution curve. Okay, so your mean is in the center at the peak. Okay, where the peak is the highest here. Okay, that's your mean. Anyways, there's also curve B, which is a skewed curve. You follow the tail. Okay, so if you say left skewed means here the tail is on the left, not on. Don't follow the peak height, the highest peak. Okay, so the highest peak is towards the right, but when they describe it, this is left skewed. Okay, and C is curve C is right skewed. Anyways, if it's left skewed because the tail is here, right? The median, the mean, and the mode is not at the peak here, slightly towards the left also. Likewise, for the right skewed is on the right side of the peak. Here is another curve that shows you the different shape. Okay, we can see here that curve B is more flat. More flat means that there are less data in the center here. Okay, if you have more data in the center, it'll be very high at the peak here, like curve A. Okay, so curve B has less data in the center. So where all the data go then? Towards the sides here. So if there's more data towards the sides here, as you can see here, it's higher than the curve A, right? This means that there are more data further away from the mean here. So if you have more data further away from the mean, you have greater spread, and therefore curve B has a higher standard deviation. High standard deviation means the curve is more widespread, the data is more widespread. Okay, so the curve may change, even though it's similar, okay, left, right, and all that, and there's a peak here, but can be slightly taller, can be a bit lower, okay, more thick, and so on. Yes, this is what I mentioned just now. Less data closer to the mean for curve B, so it's a wider curve. There's more data on the right and left side. That's why it's more widespread. Whereas for A, a lot of data very close to the mean. That's why the mean side here is very high. Right? Okay, this one same, everything same except the curve A is on the left side, curve B on the right. This means that the mean is different. Okay, the shape is the same, means the same standard deviation. So curve A, the mean is a bit to the left. That means it's lower. Curve B on the right side is higher, the mean. Here both are different, mean and standard deviation. So you can actually find the areas under the curve and find out how many percent of your data falls within a certain range. Okay. So the area is bounded, okay, under the Z value. So actually, if you remember your last lecture, right, we find the alpha over 2 here, the 95%, then divide by 2 and so on, right? So actually that one, then how many percent is the area under the curve? Okay, that means it's 0.475 is actually 47.5% of the area. Then you can actually find the Z value, which if you have been listening to the last lecture, you should be able to find. Okay, never mind, I still go through again later. Okay, so this one. So if my Z value is 1.65, what is the area? So now it's the opposite of what you did in your previous lecture. So now they give you the Z already. Eh? Z 1.65. Let's make this okay. 1.65. This is my Z. So I wanted to find the area here. So I can reverse using the Z table as from your last lecture. Okay. Okay, last lecture you have a, let's say you have 95%, you divide by 2, you get 0.475. Then you find what's the Z value, 1.96. But now you are given the Z and you now have to find the area inside here. So actually this is a bit easier. So let's see what was the question again. 1.65. So simple, you just go straight to the Z straight here. Oops. So 1.65, right? So 1.6, this is first DP, right? Then you just go across. And then the second DP is 5, right? 1.65. So you just go to 5 here. And therefore, the area is 0.4505 or 45.05%. That's all. This is a bit easier than finding the area, so many number here, right? To find the Z. But now if you're given a Z, it's easier. So you just extrapolate, get down there, then you get the value. All right. So 0.4505. So same thing, 1. If it's 1, it's 1.00. Let's quickly go through this. So 1.00 is here. So 0 is here. So 1.0 also here. So 1.00 is this value lah. 0.3413. Yeah, that's all. Simple. 3413. So this one all you can try. Okay, when you're given a Z of minus negative value, right? There's no negative value in the Z table. So you take it as a positive. So you just calculate as per is 1.75. Okay, so 1.75. So one more time lah, 1.7. So it's 0.4599. 0.4599. Yeah. Okay, now we come to a bit different. So when you are given 1, this is easy, right? You find 1.00 as per the easier earlier example, you get this. But the problem is that this area now is not from the mean. If it's from the mean, you can directly use the Z table. But now, it's outside. So outside, then will be a problem. Because if I calculate the area based on 1, I find the inside area only. So how to find the outside? So this one comes from the data just now that we discussed. That the total area under the curve is 1. Okay, total area. So you go back to your curve. This whole area here is 1. So now we are at the right side here, right? So half. So the right side here is 50%. The left side here is 50%. So that means the right side here is 50%. So it's actually 0.5. But now I have the inside area from 1, which just now I calculate to be 3413, right? So if the whole area here is 0.5 and here the area is 3413, how do I get the outside area? 0.5, which is the whole area, minus 0.3413 here. The leftover is here. So whenever you get an outside area, always minus from 0.5. So that's why the working here shows that to get the value that is outside, 0.5 minus 0.3413, which you get from the Z table for Z equals to 1. But that's not what we want because that's the inside area. Now we want the outside area. Okay, so you have to minus. Same thing here. Okay, so if you use the Z table, okay, so 1.65, right? You should get an area of 0.4505. Okay, so therefore, if you want to get the outside area, you have to minus from 0.5. So 0.5 minus the value that you get in the Z table because it's outside area. Okay, next one is the inside area. So this one direct, easy. So one is 0.3413, but 3413 is only the one side here. So if you have another one on the left side, you have to do the same thing. So since it's the same, 1 and 1, so the value of the area on the left side also should be 0.3413. So you can just multiply by 2, or you can plus 3413 plus 3413. It's the same. Okay, so you must plus the areas from both sides of the curve. Same thing here, but now it's outside. So what you do is you have to find each side here. Okay, what is 2? So if you calculate 2, right, from the Z table, you should get area of 0.4772. But now it's outside. Okay, so you have to minus from 0.5. Here they summarize total because both numbers are the same. So what they do is 1, the whole area, minus 2 times 0.47. Here is 0.472. Here is 0.477. So they times by 2. And the whole area minus these 2, you get the total of the two outside area. For this case here, both right and left are different values, so you have to do one by one. You have to do the right side first, or you do the left side first. Then you do the other side. Okay, so in this case, they do 1.52 first. So if it's 1.52 and you use the Z table, you get 0.4357. But this is just the outside area. Yeah, it's the inside area. So if I want this outside area here, I have to minus from 0.5. So I get 0.0643. And then I have to do this side also. So this side, the Z is 1. So if I use Z table, you should get 3413. But because it's the outside, so 0.5 minus 0.3413. Then I get this. Then don't forget, after you get these two left and right sided area, you have to plus. Because the question asks you to find the total shaded area. Okay, this one is the opposite. So this is similar to your confidence interval lecture, whereby you are given 0.475, find the Z value. So in this case, you have to find 0.4934 inside here. Okay, so you look for 0.4934, somewhere below. It's here. Okay, so then you extrapolate lah. So I think this one is 2.4, and what is this? I think 9. This is 9 all the way up. It's 9. Sorry, 8. So it's 2.48. Yeah, that's why we get 2.48. Okay, now they give you the outside area. So we already know, right? We cannot use the outside area, but you need to use the inside area to get my Z value here. So if you are given outside area of 0.2019, you need to find the outside area first. So 0.5 minus 2019, find the inside area first. 0.5 minus 2019, you get inside area of 0.2981. Then only you go and find out where is the value. So 0.2981. Okay, 2981 is in between 2967 and 2995. Okay, so it's in between these two. So as I said, if it's in between the two, take the smaller one. from the previous lecture I mentioned. Take the smaller one. If it's 2981, it's in the middle of these two values. So it will be 0.83. Okay, 0.83. And that's it. Yeah, I get 0.83. All right. So this one, same thing. You have an area of 0.2, 0.2. This one easy lah, both in the center area. So just directly get the value from the Z table, find where is 0.2 and get the Z value. Okay, for this one, this area is 0.4 and it's outside some more. So you need to find the inside area. So 0.5 minus 0.4. So actually you need to find what's the Z value of 0.1. So you should get 0.25. And likewise here is also outside 0.2. So therefore inside area is 0.3. Okay, so get the inside area first, 0.3. Then only you use 0.3 and find the Z value. All right. Okay. So all this is quite fun or boring or what, right? So, but it never tell us anything, right? It's just like what's this Z, then area, how many percent, and that's it. So now we are going to apply this to actual real life values. Okay. So in order to apply real life values, you need to know this formula. Z equals to X minus mu divided by sigma. So you need to convert whatever real life values to Z first. Of course lah, you need to convert to Z because the real life value can be 1,000, 100,000, 0.001, nothing. Can be anything. So you have to convert this value to a Z value first. Then only you can use the Z table. Okay, so just bear with me. I think some of you don't understand what are we going to, what's the purpose of all this. Okay, so Z equals to X minus mu divided by standard deviation. So Z is the thing you want to get. X is the real life values. For example, it can be your weight, it can be your height, it can be your marks that you score. Okay, it can be anything. You put it here. Then minus your mean, divide by standard deviation, you get your Z value. Let's see this example so you can understand better. Okay, so your lab maths class test, mean is 60. So when you have this type of question, first job, draw the curve, put the center 60. Important this one. Standard deviation is 10. Find the percent of student with score between 50 and 70. So 50 is here. 70 is on the right side of 60, right? So you need to find the percent, which is the area within the curve between 50 to 70. That is what the question wants you to find. Okay? So the question wants you to find 50 to 70. 60 is here in the center. But first, I need to convert 50 because it's real life marks into a Z value. Then only I can use the Z table. So I use the formula 50, right? This is my real life value, minus my mean, 60, divided by SD, 10. I should get negative 1. So using this Z of 1, I use the Z table 1.00 to get the area of 0.3413. Okay, 3413. And then don't forget, I want to find the percent between 50 and 70. So I have to find also for 70. So 70 minus 60 divided by 10 using the formula equal 1. So it's still 1. So therefore the area is still the same. But now it's between 50 to 70. So it means that from here, 50, center is 60, 70. So I have to add up these two areas, or since both are the same in this case, you can times by 2. So therefore, the percent of student between 50 to 70 is 68.26%. So in this way, right, the statistician can actually calculate based on the marks that you score. They key in, they calculate the mean, they calculate the SD, standard deviation. they can actually find between this score and this score, how many percent. So students score between this and this, between that and that. Okay, so it makes life easier for them. Okay, same thing here. Number of students spent on computer, 3.1 hours. SD 0.5 hours. Find the percent of students with less than 3.5. So again, draw the curve. Put the mean in the center, 3.1, right? Mean 3.1. Then only you see the question. Spend less than 3.5. So 3.5 is bigger than 3.1, right? So it will be on the right side of 3.1. So spend less. So anything less than 3.5 is all shaded. And this is the shaded area, the percent that we want to find out. 3.5 less, less than 3.5. So what is all this? Anything less than 3.5. How many percent is this? All right, so we already know the left side here. Just now remember, total area of the curve is 1. So the full area here of the half of the left side here is 50%. So we already have one part here done, 0.5, 50%. Now I need to find this area. So this area will be, use the formula. This real life value is 3.5 hours, right? So I convert to Z. 3.5 minus the mean divided by SD. So my Z value is now is 0.8. Now you get 0.8, 180, right? You find the area under the curve of 0.8. 0.8 here. 80, right? So it's 2881. Oops. Okay. So 2881. So don't forget, here also you need to plus 0.5 because they say less than 3.5. So and everything goes. So 0.5 plus 281, you get 78.81%. Okay, so same thing here. Qualify for police force, you must score in the top 10%. Top 10%, so the highest score will be on the right side. So top 10% is on the most right hand most. And the area inside there is 0.1 because 10%. Okay, so this is the area of 10%. But in order to calculate, I cannot use this area, so I need to find this area. So firstly, I need to convert get the area of the inside. So 0.5 minus 0.1, I get 0.4. Okay, so what is the Z value of 0.4? So if I use the Z table, right, I should get 1.28. So this Z value is 1.28. Okay, so Z now is reverse. Z is the one that is given, I mean calculated here. You get this value already. Now you need to find the real life value. What is the real life value? Find the lowest score to qualify. So what is the score? This is the lowest score to qualify, right? More than this, you can qualify. Okay, so this is the lowest score. So I don't know. So that's why it's X, unknown. Minus mean 200 divided by 20 SD. So if you cross multiply 20, bring over, become times. I hope you know this. This cross multiplication. So X equals to 1.28 times 20. This 200 minus 200, right, bring over, become plus. So 1.28 times 20 plus 200. You must score 226 marks to be in the top 10%. So same thing here, you can go through. Okay, so select the top 25%. Same thing lah, 25% here. So, but it's top 25, so it's on the right side. But you only want the center, the near the center. So you have to minus from 0.5. So in this case, it's the same. 0.5 minus 0.25, get 0.25 also. Then use it to get a Z value, use a Z table, get Z value is 0.67, and then you substitute to get your X. Okay, so it's similar to the previous question. This one is a little bit different because it's the bottom 10%, so it's on the left side now. Okay, so but the how you calculate is the same. Bottom 10 is still 0.1, 10%, right? 0.1. So I need to minus from 0.5 because this is the outside area. So you get an inside area of 0.4, and then use the Z table to find what is Z, the Z value of 0.4. You should get 1.28. Okay, and then you substitute. Okay, this is important because lower score. So your Z value when you calculate must put negative because anything that's less, that's to the left of this mean, okay, is negative. Okay, so negative 1.28. So times 15 plus 70, you should get 50. If you don't put negative here, right, it'll be like you're calculating the top 10% because it's 1.28 times 15 plus 70. So it's high score. Okay, so you should be negative 1.28. Okay, just take note of this. So same thing here again, I just playing with the values. So it's what's the question? Below 50. So below 50 is here. Okay, and they give you how many students score below 50. So you find the area lah. You find the area of 50 minus 70 divided by 15. You get a Z of 1.33. Find the area, which is 4082. But this is the inside area. Okay, but you want to score below 50. So it should be on the outside area. So you must minus 0.4. Okay, bottom 10, right? This is outside area. So you must minus from 0.5 to get 0.4. Then only you use 0.4 to get the Z value. So this one is the other one. Okay. Score below 50. Okay, so 50. This is the point. So you need to find the Z value first. But then you find the area, right? 0.4082 is inside area. Because I want to find below here. So I need to minus from 0.5 to get this. So this is my area or the percent, 9.18. But I want to find number of students. So the percent, the area, 9.18 times 160 students. This is the total. So it's about 15 students. So same thing lah, this one. So you all go and try out this one. All right. Yeah. So that's that for this lecture. Finished.